Apollo 6 was the final unmanned flight test for the Apollo Spacecraft Command and Service Modules. On this flight, launched by a giant Saturn V moon rocket, the spacecraft demonstrated its readiness to carry 3 men into space. At North American Rockwell's Space Division, the people who build the Apollo Command and Service Modules paused only briefly to watch the launch on in-plant television. The spacecraft, which will carry Wally Schirra, Don Isley, and Walt Cunningham on the first manned Apollo flight, was in the final stages of system tests before delivery to Cape Kennedy. This is a much more advanced spacecraft than those which flew the unmanned test missions. Continuing change is inherent in a program of this kind, based on increases in knowledge from research and development, ground and flight testing, and other sources. The Apollo 204 spacecraft fire in January 1967 brought into sharp focus the need for an improved hatch design and changes to reduce fire hazard in the Apollo crew compartment. There were many changes during 1967 as the Apollo spacecraft grew to maturity, but these specific needs received utmost attention. All non-metallic materials not absolutely required inside the spacecraft were eliminated. But non-metallic materials were still necessary in spacesuits, seals, wire insulation, and other uses. Exhaustive flammability tests were conducted by government and industry experts to determine rate of burning and spread of flame in materials under consideration. Apollo engineer Mal Clancy was deeply involved in much of this testing.
To illustrate the nature of our problem, this material is flame-proof in normal atmosphere. When the same material is placed in a pressurized pure oxygen environment and a hot ignition source is applied intentionally, it's a different story. Here's another test. A simulated electrical wire bundle in pure oxygen pressurized to 16.5 pounds per square inch. This is the worst-case test condition and represents spacecraft pressurization on the launch pad. The sample is intentionally ignited by a hot flame at the base. The flame propagates through the flammable ties and the wire insulation itself. Here, the same ignition flame is applied to an identical wire bundle which has been modified. New beta cloth ties replace the flammable ties, and the entire bundle is Teflon wrapped. The flame does not propagate. This is typical of improvements made in controlling flame propagation in the Apollo.
In addition to the new materials, flame-retardant, fire-resistant coatings have been developed. One of these is Ladacoat, a new substance developed by North American Rockwell. This coating is brush applied to electronic components which cannot be replaced by metallic parts. At NASA's Manned Spacecraft Center in Houston, more than 140 flammability tests have been conducted in recent months with a full-scale simulated spacecraft. All flight equipment, including suits, was in place for the tests. On March 14, 1968, NASA announced that the Apollo spacecraft had been found acceptable, with a mixed oxygen-nitrogen atmosphere at launch pad pressures and with pure oxygen at orbital pressure. The enriched air will be used on the launch pad for the first manned Apollo flight later this year. Design and fabrication of the new Apollo hatch resulted in a single, quick-opening door for fast escape in a launch pad emergency. Earl Holman of Apollo Engineering was responsible for design of several new hatch features.
The basic requirements were to make a quick opening hatch. Our hatch had to fit within the framework of the present command module structure, with very little change to the structure. And also, to make it fast opening, we had to activate it from one input point. It's not like just having a single doorknob and a latch. You actually have to clamp this rather large door down against a seal. And of course, the hatch had to be designed to operate in space and be left open in space.
The hatch was installed on an Apollo test command module, and a critical design review was conducted at North American Rockwell by the engineers who designed the hatch and the astronauts who would use it in actual spaceflight. The Apollo 6 test proved the hatch under spaceflight conditions. Keeping pace with improvements in Apollo spacecraft design are the revolutionary improvements continually evolving in manufacturing techniques and equipment. Some of the highlight examples are temperature and environmentally controlled areas for assembling the more than 20 miles of spacecraft electrical wiring, three-dimensional simulators where the configuration of the harness can be precisely determined before it is installed in the spacecraft, and manufacturing aids in which the wires can be moved or stored without bending or stress. New tools, many of them developed by the technicians who work on the Apollo. This one cuts ties without danger of damage to electrical wires. This brazing head makes a better, more reliable steel tubing joint and can be used at a distance of several hundred feet from the power source. This vacuum attachment on a hand drill draws away chips and dirt so that work areas are not contaminated. This solder tool clamps by itself, freeing the technician's hands and allows easier soldering of more inaccessible tubing joints inside the spacecraft. This tool accountability kit, developed also by North American Rockwell employees, gives fast visual accounting of tools to prevent them from being accidentally left in the spacecraft. These developments and others have contributed greatly to the Apollo program, and their value in use throughout industry is apparent. The design of new work stands for the installation of systems in the Apollo command module has contributed greatly to the efficiency of this important phase of Apollo production. The stands were developed by Marv Long, Apollo Facilities.
The most difficult thing to deal with has been the command module's shape itself, the conical shape. We have, through human engineering, located the module at the right height for the person on the floor, and essentially located all other heights around that height.
New tools, new techniques, new materials, continuing development and test. The most spectacular testing has been, of course, the flights of unmanned spacecraft. The Apollo 4 and Apollo 6 tests saw Apollo command and service modules launched into space on the first flights of the huge Saturn V rocket. Photographs from the spacecraft revealed the contour of land and sea on the Earth's surface, the coast of Georgia, the twin cities of Dallas and Fort Worth. And the full circle of our Earth. Cameras looking through the Apollo 6 spacecraft windows brought back a preview of what the astronauts will see during the fiery re-entry on return to Earth from the Moon. But these flights are no more important than the structural tests of the Apollo, which proves its strength under any conceivable condition. In another test at the NASA Manned Spacecraft Center, astronaut Gordon Cooper enters a spacecraft which is given acoustic vibration testing to determine the effects of certain launch and boost conditions on spacecraft and crew. Another full astronaut crew, Joseph Kerwin, Joe Engel, and Vance Brand, will man an Apollo Command and Service Module for testing in a giant thermal vacuum chamber at the Manned Spacecraft Center. No one test is all important. The full range of tests must be completed successfully before the first manned flight. At North American Rockwell, the flight crew, Schirra, Cunningham, and Isley, entered their command module for a final test of the crew compartment and all of the crew equipment before delivery to the Kennedy Space Center. Apollo, 1968. Embodiment of the most rapid growth in technical and scientific knowledge the world has ever known. Knowledge that can be applied in many fields. New materials to make airliners, automobiles, and homes less vulnerable to fire. New tools for use throughout industry and in the home to do a better job more easily. New techniques that can be applied with equal benefit to all major manufacturing and industrial efforts. Apollo, 1968. A spacecraft ready to carry 3 Americans into space, preparing for man's first voyage of space exploration across the 250,000 miles to the Moon.